at what we can do with LU factorizations. I've already have another video that allows you to be able to take this matrix A that we started with and turn it into matrices U and L. That in itself is a nice little process. It's not terribly difficult, just takes a little time. The next thing we do is then we take these matrices U and L, and then we're going to stick them with some type of answer matrix. In this case, we have the matrix that I've just kind of arbitrarily picked as 1, 2, 3 for the value B. And what this means is that A times the values of X, this actually should be X bar here and here, and all right, just like that, because those are vectors, okay? So we're saying A times the vector X, which means X1, X2, X3, whatever many values that we would need to have. In this case, this is a 3 by 3, so this would be a vector of 3 rows. And then we have B here, which has 3 rows as itself. Now, since we already know that A is equal to LU, we can replace A with LU, so LUX gives us B. If we say that UX gives us Y, then LY would give us B. Now, that's a lot right there. You may need to stop, rewind, and just kind of go back over that again. But here's kind of the idea behind it. This is a lot to deal with right here, this little piece. So how do we deal with it? What do we do with it? Well, I can do this, L or UX is equal to Y, right? Which means that Y is equal to B, which means I can actually do this process fairly simple. So here, here's my L, right? So I just took my L and I transposed it over here. So I have L times Y gives me B, right? Now notice the first position, which would be Y1. 1Y1 plus 0Y2 plus 0Y3 would give us 1, which means that Y1 equals 1, right? We do a similar process for the next one, which in this case would be 2Y1 plus 1Y2 plus 0Y3 would be 2, right? Or you have the value for Y1, which means that Y2, just stick the 1 in there, that's 2 times 1, which gives us 2, subtract to the other side, which means that Y2 is 0. And then we could do a similar process to find out that Y3 ends up being negative 2. If you want to run through that, please pause and just kind of write this out on paper. But you'd have 5Y1 plus negative 4Y2 plus 1Y3 equals 3. You plug in 0 and 1, which we just found, and that gives us that value right there of negative 2. Now what, right? That's the exciting piece. Now take these values for Y and put them here, because what we now know is that UX bar gives us Y bar, right? So, or these vectors here. So we just found the values of Y, so let's plug them in right here. So now we have 1, 0, and negative 2. And by the same exact process that we did here, except using the x's, and this time we're going to start at the bottom, we now know that x3 is going to end up being 14x3 is equal to negative 2, which means that x3 is 1/7. All right? And you're saying, well, where would 1/7 come from? Stop, pause the video, and just write this out. You have negative 14x3 equals negative 2. All right? And it didn't come up very well, but that is a negative right there. Okay, so negative 14x3 equals negative 2, which means that x3 has to be 1/7. So then you can use that and plugging in backwards there, you find that x2 is going to end up being, let's see here, I'll check my notes, make sure I got it. So that ends up being 1/7 as well. And then you find that x1 ends up being 2/7. So then you are able to find the solution to AX equals B, where X here is going to be these values right there. And this is why we do LU factorization. Now, some of you are thinking, well, wouldn't it have been just as easy to have augmented matrix A with matrix B and then do row reduced echelon form? Yeah, then in this instance it might have been. It may have been just as easy. If you're going to do this by hand, you've already done half the work to get to to echelon form at this point. Is it really that much more difficult to keep going all the way through this? Not necessarily, but this is just another way to get to that same destination point. So it's not that there's one that's better than the other. It's another tool to work with, because sometimes one tool will be better and other times another tool will be better. So all we're demonstrating here is that this is another tool that allows you to be able to find the solution to your system. Hope you enjoyed. Please continue to do more math. All right, enjoy.